Hello guys, welcome back. So here we have another question from GATE 2017 on network theory. So two passive two-port networks are connected in cascade as shown in figure. A voltage source is connected at port 1. So this is the figure. There are two ports and one voltage source is connected in the input of port 1. And they are given few details about the two-port parameters of each network. And they are given A1 to D2 are the generalized circuit constants. And if the Thevenin equivalent circuit at port 3 consists of a voltage source Vt and an impedance Zt connected in series, then they are asking what is Vt and Zt. So let us take this, put it here. So now looking in from here, we have a Thevenin voltage source Vt and impedance Zt. So they're asking what is Vt and Zt. So this question is again straightforward only. So first let us go ahead and find Vt. Okay. So Vt is nothing but your open circuit Thevenin voltage, right? So if it is open circuit, your I3 will become 0, right? So now using these circuit equations, we need to find Vt in terms of V1, eliminating all these I1, I2, V2 and I3. So I3 already we know it is 0. Then how does this 2 modify? So your V2 is equal to A2 V3 and your I2 is equal to C2 V3. Okay. So your V3 is equal to V2 by A2. So now what is your V2? So from our first equation, V1 is equal to A1 V2 plus B1 I2. I2 in terms of V3 you already know. So V1 is equal to A1 V2 plus B1 C2 V3. So now you need to eliminate V2. So V2 is nothing but your A1 V2 is nothing but V1 minus B1 C2 V3. Your V2 is V1 minus B1 C2 V3 by A1. So let me call this 2 and this 1. So substitute 2 in 1. So V3 is equal to V1 minus B1 C2 V3 by A1 A2, right? So you bring this to the other side. A1 A2 V3 is equal to V1 minus B1 C2 V3. So A1 A2 plus B1 C2 into V3 is equal to V1. You want V3. V3 is nothing but V1 by A1 A2 plus B1 C2. So this is your Vt. So if you go back to your options, these both are wrong and any of these can be correct. Okay, so now we also need to find Zt, right? So how will you find Zt? You first need to short this voltage source. So if there is a current source, you need to open it out. If it is a voltage source, you need to short it, and only the independent sources. Here there is only one source and we shorted it. So by shorting it, what do we have? Your V1 becomes 0. V1 is equal to 0. So then what I do, let's say I connect a 1 ampere current source and then I want to find this voltage V. This is nothing but your V3, right? So by connecting this 1 ampere current source, what does your I3 become? Your I3 becomes minus 1 ampere. You need to always be careful about this direction of current. In the usual two-port network, if there is only one two-port network, your I2 might be in the opposite direction sometimes. But here, since they have only given the direction of I3, let's take it to be the same as the question. Okay, so your I3 is minus 1 ampere. So now you need to find V3. So you need to eliminate I1, V2 and I2. So substituting V1 equal to 0, the first equation becomes A1 V2 plus B1 I2. So your A1 V2 becomes equal to minus B1 I2. And your I3 is equal to minus 1. So your these two equations becomes V2 equal to A2 V3 minus B2 and I2 becomes C2 V3 minus D2. So let me call this 1, 2 and 3. So then what other equation are we left with? This I1 equation. But we actually don't need that equation. If you notice, we already have an equation relating V to I2 and we have an equation relating V2 to V3 and I2 to V3 and we just need to find V3. So what we'll do, we'll substitute 2 and 3 in 1. So 213 in 1. So then what we'll get? A1 into A2 V3 minus B2 is equal to minus B1 into C2 V3 minus D2. So it is A1 A2 V3 minus A1 B2 is equal to minus B1 C2 V3 plus B1 D2. So V3 terms all you bring to one side. We'll get A1 A2 plus B1 C2 into V3 is equal to A1 B2 plus B1 D2. So V3 is equal to A1 B2 plus B1 D2 by A1 A2 plus B1 C2. So this is same as your RTH, or here they have given it as ZT, right? So this by 1 ampere, right, which is same as this only. So for ZT the correct option is this one. So option D is the right answer. So if you notice, it took some time to solve, but nevertheless it is always going to be straightforward here, right?